As we've been learning more about inheritance, you've probably used a few different terms to refer to the different levels in the inheritance hierarchy. Let's look at an example for a series of objects that define different individuals within a school system. You might call something that's higher up the tree, like in this case school member, the parent. And you might call something that's lower down in the tree, like the administrator, the child. Well, it turns out there's a formal term for this in Java, and it's called the superclass. The superclass refers to any class that is the parent or above another class. So in this case, school member would be the overall superclass of all the other objects. Staff is going to be considered the direct superclass of teacher because teacher directly extends staff. And in the same way, student is the superclass of freshman because freshman directly extends student. So why is this keyword super important? Well, we know that our subclasses or our children, when they extend a superclass, they inherit all the fields and methods. But when you inherit different behaviors, they sort of adapt to whatever class they're in. So sometimes you can lose functionality when this inheritance happens. Sometimes you want to specifically reference whatever was happening in your superclass before you altered it. This is where the super keyword comes in. Let's say you're overriding a method, but you don't want to forget how your superclass implemented it. Well, if you want to use your superclass's version of an overridden method, or really of any method, you simply put super dot and then the method name. Then it's going to look one level up to whatever you inherit from and use that implementation of the method instead of whatever is contained within your class. You can actually do the same thing with fields. Super dot field name accesses your super's fields. Let's look at an example. Let's say we have an object called staff, and it implements a method called getSalary. Now we're writing our administrator object, and it extends staff. So we know that it's going to inherit this getSalary method, but maybe we want its salary to do something a little different. Well, then we exactly reproduce that method header to override the method and replace it with our new behavior. But we don't want to completely re-implement all of the code we wrote before. We just want to add on to it. So now we can add a call to the superclass's method and then say add on a little bit of extra money to just add on to behavior and save ourselves writing extra code. It also maintains the relationship. As opposed to re-implementing this, now we know that the administrator is always going to get a little bit more money on top of a general staff member. So if we change things in our superclass, those changes will be reflected in our code for our child class. It gets a little tricky when you start talking about constructors. Only default constructors are inherited, which isn't super obvious because default constructors are implicit. You don't ever actually type them. For example, if we have a school member object and we don't do anything with its constructor, it just is implied as a no parameter, no behavior constructor. So when we have an object called staff that extends school member, we don't have to write a constructor. It's inherited. Nothing explicit here. But then let's say we want to add an explicit constructor to our superclass, meaning we're not going to get that implicit default constructor anymore. Let's say you're writing school member and you want a constructor that takes in a parameter to set the name, just sets the field. Now that we have a defined constructor, we don't inherit a constructor for our subclass anymore. And when we try to compile it, now we get a compiler error because it doesn't have a constructor. It can't inherit this thing that we explicitly wrote. Instead, we need to give our subclass an explicit constructor that passes along the behavior that we want to the super constructor. In order to do this, you use the super keyword in a set of parentheses, and then it acts just like any constructor. You can pass in parameters as you like. You're always going to want to call the super constructor as the very first line in your subclass's constructor. And then if you have extra behavior to do on top of it, you can do it after that. But in fact, this is a complete implementation of adding a constructor to the child class. Now it'll finally compile. Super can be a very powerful tool in helping you form stronger relationships between superclasses and their child classes, because now you can always make sure that your child class will represent any changes you make in the superclass by adding that behavior in instead of re-implementing it. So getting to use super is going to help you reduce redundant code and form stronger relationships between your code objects.